topic of discussion is hydrogen and its compounds. Let's do some multiple choice questions based on this chapter, hydrogen and its compounds. Question number 1. The number of neutrons present in the nuclei of protium, deuterium and tritium respectively are. See, protium, deuterium and tritium are 3 different isotopes of hydrogen. Hydrogen has 3 isotopes. Namely, protium. Protium can be represented as 1H1, deuterium 1H2 and tritium. Tritium is 1H3. So, they differ in their mass numbers. Mass number of protium is 1, deuterium is 2 and tritium is 3. They actually differ in the number of neutrons present in the atom. All of them have 1 proton, but then they differ in the number of neutrons. This has 2 neutrons, this has 1 neutron and this has no neutrons. Look at the options. First option 0, 1, 2, second option 2, 1, 0, third option 1, 0, 2, fourth option 2, 0, 1. We need to decide the number of neutrons present in each case. So, protium has no neutron, deuterium has 1 neutron, tritium has 2 neutrons. So, the correct answer therefore is first option. First option is the correct answer. Question number 2. Approximate percentage of purity of hydrogen produced from electrolysis of aqueous barium hydroxide between nickel electrodes is. First option 90%, second option 95%, third option 98%, fourth option is greater than 99.95%. For your information, let me tell you that purest form of hydrogen is obtained by electrolysis of barium hydroxide solution using nickel electrodes. That gives purest form of hydrogen. So, the correct answer for this question is fourth option. It is barium hydroxide with nickel electrodes which gives purest form of hydrogen, and it is greater than 99.95%. Answer is fourth option. Question number 3. Syngas is a mixture of. First option carbon dioxide and hydrogen, second option carbon monoxide and hydrogen, third option carbon dioxide and water, fourth option is steam and hydrogen. The correct answer is second option carbon monoxide and hydrogen. This mixture is called as water gas, also called as synthesis gas or syngas. So, the answer is second option. A mixture of carbon monoxide and hydrogen is called as syngas or water gas. Question number 4. Which of the following is a coal gasification reaction? First option carbon solid plus water gas gives rise to carbon monoxide plus hydrogen. Next, carbon monoxide plus water gives rise to carbon dioxide and hydrogen. Third option carbon solid plus water gas gives rise to methane gas plus oxygen. Fourth option is C plus CO2 gives 2CO. The correct answer is first option. Formation of water gas is called as coal gasification. Here red hot coke is used and we pass steam. When you pass steam or red hot coke, you get a mixture of carbon monoxide and hydrogen. This mixture is called water gas and the reaction is called as coal gasification. Therefore, correct answer is first option. Question number 5. The catalyst used in the water gas shift reaction is. First option sodium arsenate, second option manganese dioxide, third option is cobalt and fourth option is iron chromate. This is a memory based reaction. We need to remember the catalyst. The catalyst is iron chromate. The answer is fourth option. Look at the equation. Water gas shift reaction is this reaction. CO is made to react with steam and you get CO2 and H2. This reaction is used for the preparation of hydrogen gas. This is what you get, hydrogen gas. This reaction is called as water gas shift reaction. Catalyst used in this reaction is FeCrO4. Iron chromate is used as a catalyst. Iron chromate. So the correct answer is fourth option. Question number 6. Which property of hydrogen and deuterium are similar? First option melting point, second option boiling point, third option enthalpy of bond dissociation, and fourth option is internuclear distance. See, you need to know that hydrogen and deuterium are related to each other as isotopes. Isotopes have same atomic size. Because atomic size is same, their internuclear distance will be same. So the correct answer is fourth option. Whereas isotopes differ in their physical properties. Melting point, boiling point, enthalpy of dissociation, that is bond dissociation energy, are physical properties. They are different for these two isotopes. They have same internuclear distance. Internuclear distance is also called as bond length. So the correct answer is fourth option. This distance is called internuclear distance. This is called bond length or internuclear distance. It is same for isotopes. Question number 7. Which of the following has highest bond dissociation enthalpy? First option fluorine, second option hydrogen, third option chlorine, fourth option bromine. And the correct answer is hydrogen. Hydrogen has highest bond dissociation energy. The reason is due to small size. Due to small size, bond length is shortest in hydrogen. That's the reason why its energy is highest. So strongest bond among them is H2. Answer is second option. Question number 8. The halogen which can react with H2 in presence of catalyst is first option chlorine, second option fluorine, third option iodine, fourth option bromine. Let's look at the reaction. The generalized reaction is like this: H2 plus X2 gives 2HX. This is generalized reaction. Now X can be fluorine, chlorine, bromine or iodine. And remember, the reactivity of halogens follows the order F greater than Cl2 greater than Br2 greater than I2. So the least reactive among them is iodine. Iodine is so less reactive that it reacts with hydrogen in presence of catalyst, whereas F2 reacts in the absence of catalyst. It reacts violently, explosively, even in dark, even in the low temperature condition. So the least reactive is iodine, and this is the substance which requires catalyst to react with H2. So the correct answer is third option, that is iodine. Question number 9. Which of the following oxide can be reduced by hydrogen? First option zinc oxide, second option copper oxide, third option magnesium oxide, and fourth option is calcium oxide. The correct answer is copper oxide. See, among the options, if you see, the only metal which is present below hydrogen in the activity series is copper. So copper oxide is thermodynamically least stable among them, and it can be reduced easily even with hydrogen gas. See, as you go down the series, activity series, this thermal stability of oxides decreases. So the one which is present at the bottom is the least stable oxide, and it can be reduced most easily. So the correct answer is second option, copper oxide. Look at the equation: CuO plus H2 gives Cu plus H2O. This is how the reduction takes place. Copper oxide is reduced to copper metal. Question number 10. Catalyst used in the hydrogenation of vegetable oils is first option nickel, second option cobalt, third option iron, fourth option zinc oxide. And the correct answer is nickel. Oil adds up hydrogen gas in presence of nickel catalyst, and you get solid fat. This is a liquid, this is a solid. The catalyst used is nickel. The correct answer is first option, Ni. Question number 11. Conversion of olefins into aldehyde is involved in the reaction of first option hydrogenation of oils, second option Kolb reaction, third hydroformylation reaction, and fourth option is coal gasification reaction. The correct answer is hydroformylation. Look at the reaction. For example, ethene reacts with carbon monoxide, and this reaction takes place in presence of water, in presence of cobalt catalyst, and get this is called as hydroformylation reaction. The product is propanal. The reactant is ethene. It is called as hydroformylation. Propanal is an aldehyde. So the correct answer is third option. Question number 12. Carbon monoxide gas plus 2 hydrogen gives methyl alcohol. Catalyst used in this reaction. This is the reason water gas is called as synthesis gas. It is used to synthesize a very important, commercially very important substance, methyl alcohol. So in this reaction, the catalyst used is what? Let's find out. First option is nickel, second option is platinum, third option is palladium, and fourth option is cobalt. The correct answer is cobalt. In presence of cobalt, carbon monoxide and hydrogen combine to give methyl alcohol. Answer is fourth option, cobalt. Question number 13. In atomic hydrogen and oxyhydrogen torch, highest temperature is generated due to which of the following processes? Let's look at the options. First option, dissociation of hydrogen molecules into hydrogen atoms. Second option is recombination of hydrogen atoms on welded surface. Third option, electric arc used to associate hydrogen molecules. Fourth option is reaction of hydrogen atoms with metal surface to be welded. Look at the reaction which actually takes place. H plus H gives rise to H2 plus energy. See, imagine this is a joint which is to be welded, and this is to be welded, right? So this metal will act as a catalyst for this reaction. So on this at the joint, this reaction takes place and energy is produced. This energy will produce sufficient amount of heat which will melt the metal, and the two molten metals will join. On cooling, the joint will get welded. So the metal which is to be welded will act as a catalyst, and at the surface at which welding has to take place, there is a combination of hydrogen atoms to give hydrogen molecules. The heat produced in this reaction will melt the metal, and the metal will get welded. So the correct answer is second option, that is recombination of hydrogen atoms on welded surface. Question number 14. Which of the following hydride is having covalent nature? First option NaH, second option HF, third option KH, fourth option is calcium hydride. Remember, alkali and alkaline earth metals form ionic hydrides. Transition metals give rise to interstitial hydrides, and others give covalent hydrides. If you look at the second option HF, there is a combination between two non-metals, hydrogen and fluorine. Such a compound is expected to be covalent. So the correct answer is second option HF. HF is a covalent hydride. The other three, NaH, KH and CaH2, are ionic or saline hydrides. Answer is second option. Question number 15. Which of the following is a polymeric hydride? First option calcium hydride, second option NaH, third option MgH2, fourth option is LiH, and the correct answer is third option magnesium hydride. See, there are two hydrides, namely beryllium hydride and magnesium hydride. These two are examples of polymeric hydrides. These two are polymeric hydrides. They contain 3-center 2-electron bonds, also called as banana bonds or tau bonds. Look at the manner in which they are linked up. This is how the species are linked up, and you get a polymeric hydride of this type. This will continue. So there are two hydrides which are polymeric. Beryllium hydride is one example, another hydride is magnesium hydride. Answer is third option. Question number 16. BF3 reacts with NaH to give a compound X along with NaF, and then this compound X reacts with LiH to give another compound Y, and we need to find out what are X and Y in these reactions. Now we know that when BF3 reacts with a reducing agent NaH, we get NaF plus diborane B2H6. Then B2H6, this is compound X, B2H6 reacts with LiH and you get LiBH4, lithium borohydride. Therefore, the correct answer is second option. X is B2H6 and Y is LiBH4, lithium borohydride. Question number 17. LiH reacts with the dimer of AlCl3, that is Al2Cl6, and you get compound X along with LiCl. This compound X reacts with BF3 to give another compound Y along with LiF and AlF3. Y reacts with LiH to give LiBH4. Let's try to find out what are X and Y in these reactions. The first reaction is LiH is made to react with Al2Cl6 and you get LiAlH4, lithium aluminum hydride along with LiCl. This is compound X. Now BF3 plus compound X, that is lithium aluminum hydride, you get LiF plus AlF3 plus B2H6 diborane. This is compound Y. Then diborane, we know diborane reacts with LiH and the product formed is LiBH4, lithium borohydride. So the correct answer is fourth option. X is lithium aluminum hydride and Y is diborane B2H6. Question number 18. Which of the following is not a saline hydride? Another name for saline hydride is ionic hydride. Ionic hydride is also called as saline hydride. We know that alkali metals and alkaline earth metals form ionic hydrides, so except beryllium and magnesium. So the correct answer is second option. First option Kf, third option NaH and fourth option LiH. These are ionic hydrides. The second option, that is beryllium hydride, is a covalent polymeric hydride. So answer is second option BH2. Question number 19. Example for electron deficient hydride. First option CaH2, second option ammonia, third option B2H6, fourth option is CH4. The correct answer is third option B2H6, because if you draw the Lewis structure of B2H6, you will run short of electrons. Number of electrons are less. So B2H6 is an electron deficient hydride, while ammonia is an electron rich hydride, methane is an electron precise hydride, and calcium hydride is an ionic hydride. CaH2 is ionic hydride, ammonia is electron rich hydride, methane is electron precise hydride, and B2H6 is electron deficient hydride. The correct answer therefore is third option, B2H6. Question number 20, electron precise hydride in the following is: first option NaH, second option B2H6, third option is ammonia, fourth option is methane. The correct answer is fourth option, methane. Methane is an electron precise hydride. You can see in methane the central atom carbon is surrounded by 4 bonds. 4 hydrogens are covalently linked to carbon, so it has octet configuration. It has octet configuration without any lone pair. No lone pair is present, therefore it is electron precise hydride. So the correct answer is fourth option, methane is electron precise hydride. Question number 21, the element of group 6 which forms hydride is, see 7, 8, 9 groups 7, 8 and 9 of periodic table, they do not form hydrides. So this portion of the long form of periodic table is called hydride gap. Hydride gap. Hydride gap corresponds to the portion of periodic table in which you have 7, 8, 9 groups. In the sixth group, only one element forms hydride, chromium. Chromium is the only sixth group metal which can form hydride. Molybdenum and tungsten, they do not form hydrides. Only one element, that is chromium, forms hydride. So the correct answer is third option, Cr forms hydride, molybdenum and tungsten do not form, even Sg, seaborgium, does not form hydride. Question number 22. In which of the following hydrides the law of constant composition does not hold good? Law of constant composition is also called as law of definite proportion. Law of definite proportion does not hold good for which of these? Look at the options. First option, calcium hydride, second option is lithium hydride, third option is nickel hydride, and fourth option is methane. You know, among these hydrides, the only interstitial hydride is nickel hydride. So nickel hydride, because it is interstitial hydride, there is no bond between nickel and hydrogen, so there is no fixed composition of substance nickel and hydrogen. So the answer is third option. For NiH, the composition is not constant. Law of constant composition is not applicable because it is an interstitial hydride. NiH is interstitial hydride. Interstitial hydride means hydrogen occupies interstitial spaces and there is no fixed composition. Answer is third option. Question number 23. Which of the following metal can accommodate large volume of hydrogen? The answer is, look at the options. Options is first option cesium, second option actinium, third option is platinum, and fourth option is nickel. The correct answer is third option, platinum. Platinum can absorb large quantities of hydrogen gas. This is called as occlusion. Occlusion. Large quantities of hydrogen gas gets occluded in the voids of platinum in the interatomic spaces, and this is called as occlusion, and platinum can hold large quantities of hydrogen gas. Answer is third option. Question number 24. Open type structure of ice with wide holes is due to, first option, covalent bond between O and H, second option, intramolecular hydrogen bond, third option is intermolecular hydrogen bond, fourth option is bent structure of water molecule. The correct answer is intermolecular hydrogen bond. Due to intermolecular hydrogen bonding, the water molecules have large intermolecular spaces, and this will give open type of structure to water molecules. The correct answer is therefore third option, intermolecular hydrogen bond. Question number 25. Which one of the following contains only coordinated water molecules? First option is CrH2O taken 6 times Cl3, second option is CuSO4.5H2O, third option is BaCl2.2H2O, and fourth option is NaCl.2H2O. Actually, NaCl.2H2O does not exist. It has been just added as an option. First option is the correct answer, because all the 6 water molecules are coordinated water molecules. They are all linked to chromium through dative bond. So the correct answer is first option. Question number 26. Which one of the following soluble salts are responsible for permanent hardness of water? First option, sulfates and chlorides of calcium and magnesium. Second option, hydrogen carbonates of calcium and magnesium. Third option, carbonates of calcium and magnesium. Fourth option is hydroxides of calcium and magnesium. The correct answer is first option, sulfates and chlorides of calcium and magnesium. For your information, let me tell you that water can be classified into 2 types. One is soft water and the other one is hard water. This readily gives lather with soap. This does not readily give lather with soap. This is caused due to soluble salts of calcium and magnesium. Hard water is further classified into 2 types, temporary hardness and permanent hardness. This is caused due to hydrogen carbonates of calcium and magnesium, whereas permanent hardness is caused due to chloride or sulfate of calcium or magnesium. So chlorides and sulfates of calcium and magnesium can cause permanent hardness. Bicarbonates, that is hydrogen carbonates, cause temporary hardness. Question number 27. In Clark's method, chemical added to hard water to remove its hardness is first option calcium oxide, second option calcium carbonate, third option is calcium hydroxide, fourth option is magnesium hydroxide. See, Clark's method is a method of softening of hard water, and it works for removal of temporary hardness. Milk of lime is added to hard water and you get a precipitate of calcium carbonate. So milk of lime is nothing but suspension of calcium hydroxide. CaOH taken twice is its suspension is called as milk of lime, and it is used for softening of temporary hard water. Answer is third option. Question number 28. Hard water is passed through cationic exchange resin. This process results in water free from calcium and magnesium, and its pH at 25 degrees Celsius is first option greater than 7, second option less than 7, third option equal to 7, fourth option either first option or second option. See, cation exchange resin will take up all the cations present in water and exchanges these cations with H plus ions. It will resemble like this RSO3H. This is a generalized representation of a cation exchange resin. When it reacts with, say, calcium, it will take up calcium. You get RSO3 taken twice, Ca, and it will release H plus. These ions will be released in water. As a result, solution becomes acidic and its pH goes below 7. So therefore, the correct answer is second option. Question number 29. Exhausted cation and anion exchange resin beds are regenerated respectively by first option dilute alkali and dilute acid, second option dilute acid and dilute alkali, third option only with dilute alkali, fourth option only with dilute acid. The correct answer is second option dilute acid and dilute alkali. Look, this is cation exchange resin and this is anion exchange resin. When it works, it becomes RSO3 minus, and when this works, it becomes R4N plus. So this should be regenerated with acid and this should be regenerated with alkali. This will again become RSO3H. This will again become R4NOH. This is cation exchange resin. This is exhausted cation exchange resin. This is regenerated resin. This is anion exchange resin, exhausted one, regenerated one. So the correct answer therefore is second option, dilute acid for cation exchange resin and dilute alkali for anion exchange resin. The electrolytic oxidation of 50% sulfuric acid produces, first option H2S2O6, second option H2S2O7, third option H2S2O8, and fourth option is H2SO3. The correct answer is H2S2O8, third option, per disulfuric acid. Look at the equation. H2SO4 dissociates to give H plus and HSO4 minus. At anode, two HSO4 minus gives rise to H2S2O8 by losing 2 electrons. This is oxidation. Oxidation takes place at anode. And at cathode, two H plus picks up 2 electrons and gives H2 gas. So hydrogen gas is produced at cathode and per disulfuric acid is formed at anode. The correct answer therefore is third option, H2S2O8. Question number 31. The volume of oxygen produced at STP from the decomposition of 20 ml of 20 volume H2O2. V equals to 20 ml and volume strength is 20. And what is asked is volume of oxygen produced. Volume of oxygen produced at STP is equal to volume in ml into volume strength. Therefore, it is 20 into 20, which is equal to 400 ml. So the correct answer therefore is third option, 400 ml of oxygen is produced from 20 ml 20 volume H2O2. Question number 32. In which of the following reaction H2O2 acts as reducing agent? First option, reaction with MnO4 minus in acidic medium. Second option, reaction with ferrous in basic medium. Third option, reaction with manganese in acidic medium. And fourth option is reaction with ferrous in acidic medium. Hydrogen peroxide can act as both oxidizing as well as reducing agents. With powerful oxidizing agents like potassium permanganate, it acts as a reducing agent. Look at the reaction. MnO4 minus plus H2O2 plus H plus, you get Mn2 plus H2O plus O2. So in this reaction, oxidation state of Mn has changed from +7, it has decreased to +2. So permanganate is said to have undergone reduction, therefore H2O2 is said to have acted as reducing agent. This is reduced, so this is the reducing agent, H2O2. So the correct answer is first option, reaction with permanganate in acidic medium. Question number 33. Which one of the following acts as stabilizer for H2O2? First option alkali, second option urea, third option sucrose, fourth option dust. See, stabilizer means negative catalyst, a substance which increases stability of the substance to which it is added. Hydrogen peroxide has an ability to decompose to give water and oxygen, but there are substances like urea, acetanilide which cause stabilization of hydrogen peroxide. So urea acts as a stabilizer for hydrogen peroxide. So correct answer in this is second option, urea. Question number 34. Hydrogen economy means, first option, transmitting electric power produced from hydrogen. Second option, transmitting energy in the form of petrol. Third option, transportation and storage of energy in the form of liquid or gaseous hydrogen. Fourth option, using petrol instead of hydrogen. The correct answer is third option, safe transportation and safe storage of energy in the form of liquid or gaseous hydrogen is called as hydrogen economy. See, it is very difficult to store hydrogen because it is a very light gas with very small atomic size. It is capable of penetrating out of most of the substances in which it is stored, and it is very difficult to liquefy hydrogen. So, transportation of hydrogen is a big problem. So, hydrogen economy refers to safe storage and safe transportation of hydrogen for its use as a fuel. So, the correct answer is third option. Question number 35. The assertion is water gas is also called as synthesis gas or syngas. Yes, this is a fact. Reason: water gas is used to prepare methanol and a number of hydrocarbons. This is also a fact, and this is the reason why water gas is called as synthesis gas or syngas. So, the correct answer is first option. Both A and R are true, and R is a correct explanation of A. So, answer is first option. Question number 36. In the list 1 we have some physical properties, and in the list 2 we have physical constants. Melting point of water is 0 degrees Celsius or 273 Kelvin. So, A should be matched with 2. Boiling point of water is 373 Kelvin or 100 degrees Celsius. So, B should be matched with 3. Temperature at maximum density of water. The temperature at which water has maximum density is 3.98 degrees Celsius. So, it becomes 276.98 Kelvin. Enthalpy of fusion of water obviously can be matched with 6.01 kilojoules per mole. So, the correct answer is second option. Question number 37. We have list 1 with the methods of softening of hard water, and in the second list we have substances which are used for the purpose of softening of hard water. Look at the list 2. Zeolite is a ion exchanger. So, C should be matched with 1. RSO3H is a cation exchanger. So, it should be matched with D, synthetic resin method. Na6P6O18 is sodium hexametaphosphate called as calgon, and it is used for calgon method, and calcium hydroxide is used in Clark's method. Calcium hydroxide is its suspension is called as milk of lime, and it is used in Clark's method of softening of temporary hard water. So, the correct answer is third option. Question number 38. We have a list of various types of hydrides, and list 2 has hydrides. We need to match with appropriate type. Look, saline hydride. Ionic hydride is also called as saline hydride, and saline hydride among them is LiH. You know very well that alkali and alkaline earth metals form saline hydrides. Then electron deficient hydride. Electron deficient hydride among them is B2H6. Diborane is an electron deficient hydride. You cannot write Lewis structure for diborane using the available number of electrons. So, it is electron deficient. Then you have electron precise hydride, and among them the electron precise hydride is methane CH4. It is surrounded by 4 bond pairs, and it has octet configuration. And then one more is electron rich. Electron rich is HF, because F has got 3 lone pairs around it. So, it is octet configuration with lone pair of electrons. So, it is electron rich. Therefore, correct answer is first option. Question number 39. Assertion is ice floats on water. This is a fact. Ice floats on water. Reason: the density of ice is more than water. This is not true. Actually, density of ice is less than water. That's why it is floating on water. So, the correct answer is third option. A is true, that is first statement is true, but R is not true. R is incorrect. Actually, density of ice is less than that of water. So, the correct answer is third option. Question number 40. 10 volumes of H2O2 is equal to A, 0.3% weight by volume H2O2, B, 0.893 molar H2O2, C, 1.786 normal H2O2, D, 3% weight by volume H2O2. You need to remember this conversion factor. 100 volume H2O2 is equal to 30% weight by volume H2O2. This is equal to approximately 9m, and this is equal to approximately 18 normal. This is called as, commercially called as perhydrol. Perhydrol. Now, if you use this conversion factor, you will realize that the correct answer is second option, that is BCD. 0.893, which is as good as 0.9. 10 volume becomes 0.9, 1.8, and this becomes 3%. So, the correct answer is second option, B, C and D. With this, we have completed some multiple choice questions on hydrogen and its compounds. That's all. Thank you.